Guys, in this video, we will discuss about that how can we find a gradient of a scalar function phi. So to find the gradient of a scalar function phi, and the gradient of a scalar function phi is defined by del phi or nabla phi. This is also known as the delta phi, the delta, or you can say this as a nabla function, the nabla function. So the grad phi of this function is defined by that I into del x plus j into del y plus k into del z of phi. That means we can say that I del phi del x plus j del phi del y plus k del phi del z. And also remind one thing here, that the gradient of a scalar function gives a vector function. So now let us see by an example that how can we find the gradient of a scalar function. Suppose if we consider here the scalar function phi is equal to xy squared z, then the gradient of this function is like grad phi is equal to I into del x plus j into del y plus k into del z x y square z. This is the phi function. So now from here we can use this formula, that is I into del x xy squared z plus j into del y xy squared z plus k into del z xy squared z. So now we have to find the partial derivative of x. Here we have to find the partial derivative with respect to y, and here we have to find the partial derivative of z. So here what we get, that is y squared z I cap plus 2xy z j cap plus xy square k cap. So this is the gradient function of the scalar function phi is equal to x y squared z. So now if we have to find the gradient of a particular point ABC where ABC are real numbers, then we can say the gradient of the function phi at the point ABC is b squared ci plus 2abcj plus ab square k. And now I will discuss about how can we find the directional derivative of a scalar function. The directional derivative of a scalar function is defined by grad phi into n cap. So now there is a question that what is n cap? This n cap is the unit vector of the given direction vector. Actually, we have to find the directional derivative in the direction of some vector at a given point. So now I will show you that how can we find the directional derivative by one example. So see here, I just show you here one problem, that this question that find the directional derivative of the scalar function phi xyz x square yz plus 4xz square at the point 1 comma minus 2 1 in the direction of 2i minus j minus 2k. So see here that this is the function, given scalar function phi of xyz is equal to x square yz plus 4xz square. So now we have to find the gradient of this function, that is I del x plus j del y plus k del z into x square yz plus 4xz square. Here this is the phi. That means now we have to find the partial derivative of x, partial derivative of y, and the partial derivative of z. So here I into del x of the phi function, that is we get 2xyz plus 4z square I, then plus j into, if we find the partial derivative of this function with respect to y, we get x squared zj and plus k into del z of this function, that is if we partially derivative with respect to z, we get x square y plus 8xz k. And now if we find the grad phi at the given point 1 comma minus 2 comma 1, so if we put all the value here, we will get j plus 6k. And now see here that here we have to find the directional derivative in the direction of this vector 2i minus j minus 2k. That means now we have to find the unit vector of this vector. So the unit vector of the given vector is, if we denote that a bar be the unit vector, then a vector will be 2i minus j minus 2k by root over 2 square, that is 4, plus the component of j is 1, that is plus 1 square plus 2 square 4. So here if we simplify, we get the unit vector of this vector 2i minus j minus 2k is 1 by 3 2i minus j minus 2k. So now we have to find the directional derivative of this function at the point 1 comma minus 2 1. So here now we have to find the product of the grad phi at the point 1 comma minus 2 1 into the unit vector, that is the dot product of the grad phi into the unit vector. So if we find the dot product of the gradient into the gradient and the unit vector, so we will get here the j plus 6k dot 1 by 3 j plus 6k dot 1 by 3 2i minus j minus 2k, and if we simplify, we will get the value is minus 13 by 3. So this is the way that how can we find the directional derivative of a scalar function at a given point in the direction of a vector. So I hope all of you understand this topic. So thank you.